I'm going to talk to you about what VDAP is. We call it the Vcinity Data Access Platform. I'll show you what it's about, what it does. I'm going to show you a quick demonstration. Actually, I'm going to show you a couple demonstrations. But in between, we're going to talk about how we do this. One of the things that we've always seen is once we show the demo and people understand what is now possible that they never thought was possible before, it's all along the lines of, okay, how are you doing this? How are you doing this? How are you doing this? So that's what I'm going to do. I'm going to walk you through that process. Now, before I do that, a couple of these ground rules, right? When you come up with a technology that is so disruptive in the industry, right? It's disruptive in the terms of, how do I use information differently? How do I get access to information that's a little bit different? But I want to make sure, and I always tell people, I can give you the greatest things in sliced bread, but if you have to change anything, there's no value behind it. So these are the ground rules that we set out to start with, and the ground rules that we actually, there are our goals that we met. So first and foremost, what you're going to see as we walk through this is we're not touching the data, right? We're going to give you something that requires no application changes. This is not WAN optimization. This is not caching. There's no compression. There's no dedupe. We're going to talk about that. There's no software. There's no acceleration from the WAN perspective. There's no changes you have to make to the LAN or the WAN. And most importantly, there's no computer application or storage dependencies that we have. Now, the fundamental piece, though, as you saw from Harry, was there's no copies of data. Again, the technology is designed to say, if my compute's in one location and my data somewhere else, traditionally, what would happen is I would take a copy of that data and I would move it closer to the compute. They have to be co-located. We broke that paradigm. I'm literally going to show you technology that allows compute, pick it wherever it is in the world, to work on data wherever it's created, the instant that it's created, without moving copies around. Okay, and this is different. So let's walk through the first demo here. All right, now the best way for me to show a demo is to show a comparison. Now, again, we're compute agnostic, so I can pick the compute of choice. In this case, I'm actually choosing to use compute in the cloud. So this is Amazon, specifically Amazon on the West Coast. Now, I'm going to show you a comparison. We're going to run things side by side. So I have two instances that are running in Amazon. One is going to be doing things using the Vcinity method. In this case, it's a bookend approach. We'll talk about that. But in this demo, it's actually two VMs, one on either side. So that's going to be running the Vcinity method. Then we also have an instance that's going to be running the traditional, and you're going to see these side by side. So that's where my compute is on the West Coast. Now, my data, however, is on the East Coast. Specifically, we have a regional office right outside of Washington, D.C. in Germantown, Maryland. That's where my data is sitting. Now, again, this is not WAN op. WAN op is I'm going to take a copy of the data, I'm going to compress it, I'm going to do things to help me move that copy faster. This is also not edge caching, right? Edge caching is I'm going to predict what I think you need ahead of time, and I'm going to place copies local to you so that when you come in the morning, you can work with these copies, right? The problem with edge caching, and it helps a little bit, but the problem is if I guess incorrectly, I'm back to the same problem. Or if my data changes too frequently, right? Or if my data is sovereign or sensitive in nature, and I don't want to have copies floating around, that's where it starts to fall apart. This is different. So what I haven't done is I haven't made a copy of the data or taken the data in any way, shape, or form and moved it close to the cloud. We're literally keeping these things separate. Now, what I'm going to do is I'm going to bring up a couple windows here, specifically the instances that are in the cloud. So what I have here, this is the Vcinity method. I'm just going to run through an application. Again, we're application agnostic. I'll show you how this works. But what I'm going to do is I'm going to show a quick demo on this application. This is an open source 3D modeling tool for seismic survey data. Essentially, the boat goes out in the ocean, does a sensor sweep of the ocean floor, collects some data, and somebody decides if there's oil there or not, right? It just works on different layers. So that's what I have here in front of me. And then I also have the traditional approach, and we're going to run these side by side. And again, it works on different layers. But remember, my compute, this application is in the cloud on the West Coast. My data is still on the East Coast. So let's go ahead and fire this up. What I'm going to do is I'm just going to add in some layers. We'll start with the traditional side, and then we'll come over here to the Vcinity side. Now, at this point, I have the options. I'm going to select them all. Let's go ahead and bring in all the layers that are afforded to me to go ahead and run this demo. Now, as you see here, the checks came up on the Vcinity side. I'm going to say OK. And at this point, I'm literally doing 3D rendering over 3,000 miles. And the beauty behind this is I'm getting the same user experience as if the data had already been copied to the cloud, but I haven't, right? And if I come over here to the traditional side, this is what we'd expect. And the checks will come back and I can click OK and it'll take about another half an hour to load. But the idea is that in the real world, you wouldn't try to do this because of this effect. right? What you would do traditionally without Vcinity is you would take a copy of the data and you would move it to every single person that wanted to do something with it. And if I had 10 people in 10 different locations, guess what? I have 10 copies. I also have to have 10 landing spots, AKA storage, for that copy to land. Okay, so we're not going to sit here and wait for the paint to dry. Let's talk about how we're doing this, because I know that everybody's kind of figuring out how is this actually possible. So let's go back to the slideshow here. And let's talk about VDAP. That's what we call it, the Vcinity Data Access Platform. Now, let me give you an analogy. So we're going to talk about some concepts first. I'm going to show you a quick second demo, and then we're going to dive deep into what we actually do. And the whole point of this is to say, okay, how do I sustain throughput over distance? If you think about traditional networks, and you can have folks say, I can fill a network up. I maybe have a 10 gig network. I can fill a 10 gig pipe up, and you can. The problem, though, is if you get a couple thousand miles away, the problem is that the data is just kind of dribbling out the other side, right? Our approach is, let's find a way to sustain throughput over distance that's equivalent to a local area network, which is different, and then use that to our advantage. And if you think about this in this analogy here, right? Let's say you have unfortunately have a fire somewhere and you have a really long trough, and I'm going to put some buckets of water in there, right? Because I can't keep that pressurized, it's just kind of dribbling water through it. What's going to happen is the farther away that is, the longer that trough is, I have no actual mechanism to put out that fire. But the alternative is, let's say I found a way to put a pump there. Think of a fire truck, right? What happens now is I can pressurize that water, and all of a sudden now, 1,000 miles away, I'm getting the exact same thing as what I put in, and I can put out that fire. It's very similar to that. What we've done is fundamentally a couple different things. And somebody mentioned magic earlier, right? This people say it's only magic if you don't know how to do it. But what we've done is not one silver bullet. What we've done is we've created this marriage of a lot of different things that we've bolted together, 32 some patents across networking and file systems and things like that. And we've married them together in a way to create a solution that solves a problem, which is my data's over there. I really need it to be here. That no longer is a problem. Okay. You see terms like RDMA, remote direct memory access. That's one of the things that we use. We're going to talk about that. But the idea is that I'm going to do some unique things on the network. I'm going to do some unique things on the file system, and I'm going to make it simple and easy for people to digest on either side, specifically in terms of files and folders and shares. Okay. Now, this is what I'm going to show you next. Okay. So I keep talking about sustaining throughput over distance. Without Vcinity, this is pretty much what you have. This is a nice little graph. We have on the vertical on the left-hand side, we have throughput. And on the bottom, on the horizontal side, we have distance. And what you can see is once you start adding latency, right, or distance to the equation, all of a sudden my throughput starts to tank, right? This is the fundamental problem. This is why we make copies and move data around, right? What Vcinity has done is we took it from this graph, I'm going to show you the next chart here, to this, right? I'm going from horrible performance over distance to essentially, instead I start at 900 meg and almost 2 seconds away, I'm getting 800 meg out of this graph, right? I'm able to sustain, this is a single flow, I'm able to sustain this throughput. And when I can get 90+% efficiencies over distance, that's essentially a local area network, but we're doing it on a wide area network, okay? So let me show you another demo, and then we're going to dive into, okay, how are we actually doing this thing here? And again, I'm going to show you it's the same setup, right? We're going to do a comparison. I have 2 instances in the cloud. I'm doing compute in the cloud, but I'm doing my data somewhere else, data on-prem, data at the edge, right? The idea is to keep these things separate. So let's go ahead and fire up the next demo here. So if I come back here, I have my blue window, which is the Vcinity method. And then, of course, I have my traditional as well. I'm going to show you 2 things. Now, first, although this technology is about not moving data around, we're going to talk about that. I actually am just going to move a file. And we do that. That's kind of the other side of the coin. If you just want to move data around, backup, group migrations, things like that, we'll pretty much do that faster than anybody. But there's a reason that I'm going to show you this. So what I'm going to do is I'm just going to take this 5 gig file. We'll start with the traditional side. This is just random numbers, nothing super interesting. What I'm going to do is I'm just going to drag it from Maryland, the prem or the edge, right, up into the cloud. And you can see here we're running 6, 7, it'll maybe get to 8 megabytes a second. If I come over here to the Vcinity side and I do the same thing, same file, same network, we're just tunneling through our VMs instead of 5, 6, 7, 8, I'm getting 130 plus, right? What I'm doing is I'm actually showing you an example of how I can sustain, this is a single flow, how I can sustain throughput over distance. And if you do the math, we actually have a carve out here. What you're going to see is this is about 95.5% of the theoretical bandwidth that's afforded to me. And if I can run 90+%, that's a LAN, right? So really what I'm showing you here is I've created a global local area network, all right? And we'll go ahead and stop that. Now, it's one thing, you saw the demo earlier with 3D modeling. It's another thing to do something with video. So here's what we're going to do. We're going to show a quick demo with video, and then I'm going to talk about how the tech actually, what's going on under the hood here. So this is Adobe Premiere. I'm sure you guys are familiar with this. The content, we did the World Series a couple years ago. This is actually some of the interviews. They were kind enough to give us some of the content. These are, if you're a Cubs fan, you're going to love this. These are just interviews from some of the Cubs players, right? So what you're looking at here, let me go ahead and make this a little bigger so you can see it. So what I'm going to do, I mean, we can edit, we can do all these other things, but I'm going to keep it simple, right? I'm just going to play a file. So I'm going to take this Cubs guy, whoever he is, and drag him over here. And he'll come over here. Okay, now I'll make this a little bit bigger so you can see it. Okay, now what you're looking at in the window here on the right-hand side, top right-hand side, you see total and dropped. What that represents is the frame count, right? Premiere can keep track of the frames that it wants to see and expects to see, and which ones it didn't see, which ones are dropped. So I'm just going to play this. Now remember, the application Premiere, the associated compute AWS on the West Coast, right? But my data is still on the East Coast. So we'll go ahead and launch this, and we'll see what happens. It takes a little bit for it to get going here. There we go. So you see the frame count going up, but you also start to see the drop count going up. And the user experience is horrible, right? It's jerky, it's jittery, the video and the audio are off. If I was an editor, I'd be pulling my hair out. This is not something that you could actually do. This is why we make copies, right? Well, let me show you the alternative. So we're gonna do the exact same thing, same file, same network. I'm gonna make this a little bigger so you can see it. And I'm just gonna take that interview and drag it over to the window here. There we go. In fact, we'll make it a little bit bigger here so you can see it. Okay, now let's go ahead and play this, see what we got. There we go. So we see the total going up, but guess what? We're not dropping any frames. In fact, I could actually come here and edit. I can move around, right? If I try to do that particular thing, we call it a scrub line, but if I try to do that, so you see me click, and at some point, there it goes, right? If I was an editor, this would be horrible, right? And again, on the Vcinity side, you can see what's happening here is I actually can move around, do different things. The beauty is it's the same experience as if the data has already been co-located beside me, and it hasn't, right? That's fundamentally what this technology does. This is what's transformative in the industry. I no longer have to have my data by my compute, okay? Now, how do we do this? Because that's what everybody's asking. So how does this work? So first and foremost, it's easy to use. It's hard to do, right? I mean, there's 30 patents. It's taken us a lot of time to put this all together. But the beauty is we did it in such a way that to an end user, you can drop in without a lot of training, without a lot of changes. In fact, there's hardly any changes at all. So let's talk about that. Now, what happens is that the Vcinity technology presents like standard files and folders and shares. You saw that on the demo, right? So each location, not each user, but each location gets some part of the Vcinity portfolio. And it can be everything from a virtual machine up to some hardware assists. We're going to talk about that. So what happens is if, let's say, for example, I have an office with, 50 people, right? I only need one Vcinity thing. I just take the VM, put it on a server. It's presenting into the architecture like folders and shares, like a NAS device. So to the users, whether you're on a Mac or God forbid a PC, what happens is now you can create a folder on your desktop and just point to the local Vcinity thing that's sitting in your environment. And when you click on that folder, up comes the metadata, just like you saw in the demo. Up comes the information that looks like my data's there, although physically it's, of course, somewhere else, okay? Now, so that's what the users do. So again, when it looks like a NAS, remember, this is not WAN optimization. That's moving copies around. This is not an inline thing. I just need a port in the network and an IP address, and then off we go. Okay, so the beauty behind this is standard files and folders and shares. We're actually working on an object as well. Is that, every computer already has the ability to make folders and shares. So we're good there. There's no software you have to install. There's no agents. There's only one thing in the architecture. And there's no application changes. The only change to the app you have to make is say file open, you point to a different folder. right? And you can have this run concurrently with everything else, okay? Now, at this point, we do something a little bit different. And I teased you a little bit in the beginning. I said, hey, this is kind of RDMA. All right, so here's what we did. So we went out and we looked at TCP, and TCP is really great in the data center. It's got very good error correction. There's a lot of cool things that are happening with it, but there's a lot of chattiness that occurs, right? And when you try to do that over long distance, high latent WAN connections, it creates a lot of error in the wire per se, right? I'm waiting for the results, and it's a horrible, horrible thing to run over the WAN. So what people did was they said, we're going to create WAN optimization, and that's essentially just UDP, right? Which helps a little bit. So UDP can help. It removes the chattiness. In fact, there's pretty much no chattiness at all. It doesn't give you great throughput, but it removes that chattiness. But then what happens is you still have to have some kind of flow control. You still have to make sure that the data actually got there. So now I have to put software everywhere to make sure that it did. So I kind of just moved the problem up the stack. What we did instead is we looked at the high performance computing industry, right? So think these big supercomputers. And, we said, okay, how do these supercomputers talk to each other? They're very efficient. They're very effective in the way that they communicate. It's essentially memory to memory transfers. That's something called remote direct memory access, RDMA. That's what you saw before with the little bus, right? If you look at RDMA, it's very lightweight, very efficient, very low latency. The problem with RDMA was that if you wanted to take it long distance, it couldn't sustain itself, right? You get it, 20 milliseconds away, 10 milliseconds away, a couple hundred miles, and all of a sudden RDMA just can't go, right? This is the beginnings of things like InfiniBand and Rocky and stuff like that, right? Some of our patents are around the fact that we figured out how to actually take RDMA and extend it on a global scale and keep it alive. In fact, we're the only company that we know of on the planet that can actually do that. So now I've taken a really good best of breed protocol and found a way to make it work over long distances, okay? Now, the problem with that is, okay, that's all well and good, you can do it, but most WAN connections don't want to see RDMA, they want to see IP. So what we did is we took our RDMA goodness that we've created, our intellectual property, and we just put IP headers on it. We just made it look like every other thing that's on the highway, right? So now we're transport agnostic. So as long as the transport can support essentially anything that looks like an IP packet, we're good to go. That means this can run on the internet. It can run on dedicated links, 5G, Wi-Fi, satellite. It really doesn't matter to us. Now, then what we did, we said, okay, that's great in the middle. And then we turn it back into standard TCP/IP folders and shares, NFS, SMB, CIFS kind of thing, to the users. Because we want to make sure that whether I'm pulling information from storage, we're going to talk about that, or my clients, I just want it to look like folders and shares. And I abstract everything else in the middle. So the nice thing about this is you can drop it in, it's non-disruptive, people understand how to make folders and shares, right? And then they can use this kind of thing. Now, we already mentioned that, hey, this isn't based on compression or dedupe. Remember, it's not TCP, it's not UDP, we're not compressing the data, we're not deduping the data. As Harry mentioned, it was the federal government that asked us to create this technology. And in some cases, the data might have been encrypted. And if you rely on compression, you're not going to get much compression on encrypted data. So we couldn't use that technology. Okay. Again, we're transport agnostic. Now, what I'm going to do is I'm going to actually show you something about security. But before I do that, people always say, okay, I get what you're doing. You're using RDMA. It's a really good protocol. You're making it look like folders and shares. It's easy for people to use. But how do you get around latency? And if you're not moving copies of data, what are you moving? Because you got to move something. Okay. So let's talk about that. I always use my laptop as an analogy. So let's say I bring up an application on my laptop. Maybe it was that Adobe Premiere, right? So I have a Premiere running on my laptop, and I have a hard drive on my laptop, and maybe I have a 300 gig file, right? What you don't do 90+% of the time is move the entire contents of that 300 gig data set into memory. What happens instead, I'm sure you guys know this, right, is you listen to the file system and the operating system, and you say, oh, the application would like this piece of the data. I would like these layers. Maybe it's a drone footage. I don't care when it takes off. I don't care when it lands. I want to know what happens in the middle, right? So what happens is, and each application works a little bit differently, but they're essentially saying, I would like this piece of the file. And you do a little read ahead. You're just moving chunks of the data from the hard drive into memory. You're doing memory transfers, okay? Now, if I take that hard drive out of my laptop and I ship it to somebody that's on the West Coast, I'm on the East Coast, I ship it to somebody that's on the West Coast. And if I can do the same thing, meaning that I have the intelligence and it's distributed in nature to pay attention that says, oh, this client, this application would like this piece of that file. I go out over distance, I grab that chunk of the file, I turn it into that high-speed memory transfer thing that I've wrapped in IP, and I bring it up and I give it to the application. If I can do that process fast enough, the application doesn't know the difference. And that's fundamentally what we're doing. Now, let's talk about latency, because this is kind of a setup to that. You can say, okay, so you're only moving the pieces, you're using RDMA, I get all that kind of stuff. How do you get around latency? So here's what happens. Is there's always physical latency on the link. On the demo, it was 70 milliseconds, right? Back to the Disney and Magic kind of thing. If we can get rid of that, that would be really cool. We haven't, but I can mitigate the effects of it. So here's fundamentally what happens, is that as that first chunk of data comes across, it will always incur, the first bit will always incur the physical latency of the link. However, and you saw in the demo that I can sustain 90%, I can pressurize that pipe, whatever way you want to talk about it, is that every bit after the first, the second bit comes right after the first, the third right after the second, because it's at that 90% efficiency. What will be essentially done is created a local area network after the first bit. So I didn't remove latency, I minimized the effects of it after the first bit. And the beauty behind that is most applications can tolerate that first initial hit of latency. They just don't want to pop it up all over the place. You saw that in the Adobe Premiere demo, right? If latency is randomly showing up and there's all the air in the wire and it's horrible, right? What we do is, if it takes an extra 70 milliseconds to play the video, so what? But after that, it's a LAN. That's fundamentally what we've done. Now, let's talk about security real quick. So a couple of things. People always say, okay, what are you doing about permissions and things like that? Okay. So the idea behind what we've created is that regardless of where the compute and the users and the application are and where the data is, they're separated by the whole globe, but we want them to have the exact same experience as if the data and the computer are sitting right beside each other, the traditional thing. We want that experience, even though we don't want to actually have the data by there, okay? So in terms of permissions, right? Whoever created the file will create the permissions, read-write permissions, all the ACLs, all those funny things, right? The last thing we want to do is we want to break that paradigm. So our version of security is to enhance and complement what's already there, not fundamentally change it. So you have initial permissions on the file. If somebody a couple thousand miles away wants to use that file, when they click on it, they're going to get the exact same permissions that were there originally, meaning we didn't break it. Oh, by the way, you don't have to recreate it. You don't have to add permissions to it. We just extend those and push those forward. The other thing people say is, what about locking, right? And this is application dependent. Each application works a little bit differently. But in terms of locking, it's if Harry and I were in the same, building and we had a filer right beside us, if I open it up first, I get read write. If Harry opens it up, he gets read, right? That's POSIX. And again, each application works a little bit differently, but we don't change that paradigm. We extend those locks and all that synchronization because we have a distributed file system that keeps track of all that kind of stuff. Okay. Now, the other thing people say is, okay, what about, so you're not moving the whole file, although you can, and we'll just move really fast, but we don't want to do that, right? We want to just work on the data over distance. What about data in flight? Can you encrypt data in flight? And actually, the answer is yes. So we can actually turn on encryption, AS256, or if you're in some of the government involvement, there's the new lightweight encryption, Simon and Spec. We've implemented all those things, and we do it at line speed, and that's all well and good. But we took it to the next level. So I'm going to click the next button here on the animation, and what you see is the WAN went from 1 link to 3. Okay, so we've actually created a technology, we call it Data Prism. But the idea is that if I have the ability to have multiple WAN connections at my disposal, and they can be different latencies, we'll normalize it. That's just what we do. But what happens is now, and you see 3 here, we can go up to 8. But what I can do is I can take a single flow data, and we can have thousands of flows, but I can take a single flow of data and I can carve it up and stripe it or spread it across those links, right? The first packet goes on this link, the next one goes on this link, and you kind of get the idea, right? And then I could put a unique encryption key on each link, and I can dynamically change them. So what happens now is you see 3 links here. If somebody got a hold of a link and its key, then they got a third of the data, right? So we've created obfuscation. And again, we can do this all at wire speed. So now what happens is, by policy, you can say this sites can see some of this data, not this data. And oh, by the way, we've created an encryption paradigm that allows you to really obfuscate the data, right? So I did want to show you that. Okay, so here's what the portfolio looks like. And then I have one slide, we'll finish it up. The idea is it's really speeds and feeds discussion, right? You can have everything from a virtual machine. That's what you saw in the demo. We say the VM can run, between 1 or 2 gig. It's very kind of conservative in nature. The more hardware you throw at it, it can be hypervisor choice, bare metal, cloud. If you need more than a couple gig and you want to scale out, think hub and spoke, then we'll throw some hardware assist at it. And it's everything from a small little PCI card that you can put in a server. And remember, that server could just be essentially a data server, a folder or a share kind of server, almost like a NAS, right? Or we can throw some bigger hardware at it, gigs, and it works together. It's really who do I want to talk to, how many people, and well, you just choose what you want, right? So just in summary, very straightforward stuff, right? You have to address a lot of different things. Again, this is not WAN off, that's moving copies of data around. It's not caching, that's preloading copies of data, right? The idea is let's do something on the network. We already talked about RDMA. One thing to note here, you see the term lossless. The idea is that you don't want to put data on the wire because we're gonna pressurize that pipe, and you can define how much we have to work with. You can tell us you have 2 gig of the 10, so there's controllability there. But the idea is that I don't want to have data that I put on the wire and then have it get to the other side and it wasn't ready to receive it and it's dropping the data. Okay, so what we do is very similar to some of the storage technologies where I'm going to wait for kind of an acknowledgement or a credit, right? I always use, well, I haven't done in a while, but I used to use an analogy. So I've had teenage kids, right? Where if, I'm trying to talk to my daughter, bless her heart, and she's on the phone, my conversation is going nowhere, right? My everything's getting dropped in the bit bucket. The better approach is wait till, she gets off the phone. She says, what would you like to say? She's ready to receive data. Same thing happens. So we're not going to put data unless the other end, the other piece says, okay, now I'm ready to receive data. And oh, by the way, you can send this much. And then I have pretty much a fighting chance, a guarantee that I'm going to get data out there and it's going to get there and everything's going to be okay. That creates that lossless type of network. The other thing I'll add here before we go and finish it up is, people say, okay, you're not using TCP, you're not using UDP with all the agents. What happens if you lose data, right? So one of the things that we've done is it's very similar to TCP is we'll actually throw labels or sequence numbers on some of the packets and we'll keep track of that. Now, remember, it's a booking approach, although one can talk to many, you can do hub and spoke, all that kind of stuff, is that the Vcinity initiator, right, at one location is sending data, maybe send 100 packets. The Vcinity peer at the other end, the receiving end says, oh, I got 100 packets, but number 12 is bad or missing or something. We'll go back and we take it upon our responsibility to say, hey, please resend me just number 12. As opposed to do a retransmission of all the data that was in the window, restart, or lose all the data in the wire, that all goes away. And the beauty behind that is it's very fast, it's very effective, it's very efficient. And to the end pieces, it always looks like a clean network. They never saw a request for a retransmission, right? So we take that upon our responsibility. Now, as I mentioned, there's a file system that runs under the hood. It's very high performance. It's RDMA in nature. It's parallel. We get a lot of parallelism out of it. We get a lot of speed out of it. It keeps track of all the syncs and locks and ACLs, all that kind of fun stuff. It integrates with the storage, right? Remember, this is just NFS and SMB. So if you have a centralized storage pool and then you want to have hundreds of people get to it, what happens is you just take an NFS export out of that storage pool. The local Vcinity thing that's sitting there, either the VM or the hardware system, mounts that. And then logically, it looks like we stretched NFS because at the clients, they're just mounting NFS or SMB on the other side. In the middle, we've done all the stuff I talked about. But the nice thing is it just looks like folders and shares. The other piece is, everything is based on stuff that everybody already has, right? We want to make sure that you can drop this in without having to upgrade your LAN, upgrade your WAN, change your file systems, add more software, and all that goes away, right? The last piece I'll share with you here is that, we want to make sure that everything that is controllable through this architecture, how much bandwidth I want to allocate to it, what file systems, how the mount points, who can see what, I don't want to create an environment where everybody can see everything. I want to maybe lock things down, all that kind of stuff that you can do, you can tune and tweak. We have management tools to do that, but we've opened it up to be controlled externally through things like REST. So now if I have some kind of orchestrated environment, SD-WAN, or I'm doing some kind of workflow automation, or, anything like that, the idea is that, we'll take those queues and you'll be able to control this outside of, the Vcinity architecture per se. Okay. So hopefully that made sense. And again, this is different, right? It's not WAN up. It's some unique things that I think people have been waiting for a long time to get kind of the keys to the kingdom here, to be able to say, look, it doesn't matter where your data is. I can make the WAN actually perform like a WAN. So
you talk about the parallel file system and then NFS in the backend. So does it mean that so when you talk about parallel file system, you import block devices directly to your appliance and then you expose a file system from there? Or is
okay, yeah. So let's talk about blocks. So the way that this works is, anything we can bring in via NFS, we can distribute to the remote locations. In terms of block, the problem is that our file system it's not a problem, it's just a characteristic, is our file system has to own that LUN. So as long as we are in charge of that block LUN, then I can share that. Otherwise, we can't. So this is pretty much file and object. There are certain cases for block again, but we have to own that. Does that make sense?
Yeah. So you're building your file system on top of block devices that are external to your.
Correct. And actually, the file system. So just so you guys understand, we started with Lustre, and right now we're running on IBM Spectrum Scale, kind of a scale down version of Scale. So it's not our file system; it's one that's proven and robust. We've just found a way to kind of tune it and incorporate it to do these things that we've talked about.
Okay. And what happens? So if you have your file system and you have multiple devices accessing the same file system at the same time, so the same file working on the same files, things like that.
Yeah. So if you're working off the same file system, that's not a problem. Scale keeps track of that. Everybody can be doing their things. If you're working off the exact same file, maybe I have a million files in my file system, but for some reason, these two guys or people are working off the exact same file. In that case, we're going to present it as read write for the first, read for everybody else, unless the application itself is doing some kind of byte range locking or something like that. And we don't break that. We'll just take those cues. But fundamentally, that we're just doing the POSIX thing.
Okay.
Yeah, good questions. Thank you.
So you guys are using IBM Spectrum Scale as the back-end parallel file system that you're using. Is that correct?
Yeah, currently that is the one that we're primarily shipping with. Again, we've worked with Lustre, but yeah, we want to have a parallel distributed RDMA file system. Scale works pretty good for us. I don't have to have a separate metadata server. It's very lightweight. We can kind of move things around, and the beauty behind it is, we've abstracted Scale from the user, so you don't have to be a IBM Scale expert, right? We've done all that work for you. It's just folders and shares.
Right. Got it.
I think this was great. I feel like, wow. I don't know if it's magic, but you have definitely wowed me. But for me, seeing is believing, right? So is there a way we can get our hands on some of that network data, right? I kind of want to take a look at the actual protocol going back and forth. I understand It's not TCP, right? So you're encapsulating raw IP. What IP protocol number do you guys use?
So actually, the encapsulation technique we're using is L2TP. Which is, I don't know, 1007 or something, whatever it is. Right. So yeah, it's just L2TP. So that's the only port you have to open up on a firewall, is to make sure that L2TP can go across. But I can get you all the data. And just so you guys know, if you want to try this, so, we're in the Amazon Marketplace, or we can get you access to our portal, and we have, some trial virtual machines, or bare metal. You can go ahead and remember, it's a bookend, so you need two, but anybody can go in, grab two, put them in different locations, and fire away for 30 days and give it a try.
About, you have NFS in the backend and you can convert it into SMB. But how do you manage the differences between ACLs, users and things like that?
Yeah, good question. So primarily this is running on Linux. So think LDAP, right? If you're in a mixed environment, there's the RFC, I can't remember what the one is for mixed modes. We attach that out of the array. We'll grab the mappings that way. There are some unique things that we have to do, but we've got customers that are in mixed modes and, all these kinds of things. So there are other ways to kind of help through that. There's third-party tools. Scale does some of it. It's really kind of a case-by-case basis. We haven't had a problem where somebody said this isn't going to work, right? It's the biggest problem we have sometimes, for example, is that, remember, you're connecting locations together, and if they're in two different trees, then they don't have the sharing mechanism between them already set up, that's a problem. I mean, that's not something we can solve, but that's just the architect behind it. But for us, we have mechanisms to blend those two together. And it's kind of I don't say cheesy answer, but it really is a case-by-case kind of piece. Yeah, good question.
Hi, Steve. I understand that one of the prerequisites for this to work is to have your appliances physical or virtual at both locations, at both endpoints. So this is strictly for location-to-location setups. It doesn't work for roaming users. Like you still don't have the possibility of having like a client on a customer laptop so that they can have the experience while on the go. Or if not, do you have it planned for the future?
Yeah, so the answer is actually yes for the first. So, and then we're making it a little bit more robust in the future. So the way this works, just so you guys understand this, is, the VM can talk to, it's essentially meant to be an endpoint, right? I want to talk to one other thing. When you throw some hardware assist at it, maybe a core or a hub, the idea is we work on virtual tunnels. So I might have one, physical 10 gig port on our hardware assist, but I can take that port and I can carve it into, 100 different virtual tunnels, and I can associate some amount of bandwidth to that, right? Maybe I have a 10 gig port and I have 10 users, each one gets a gig or something like that, right? So what happens is that I can, scale out in terms of the core. One of the things we did on the VM is we created a call home technology, which means that as long as the virtual machine knows kind of where my other peer is, I can roam around all day long. I can get behind net. I can do different things. My endpoint can change because all it needs to know is, okay, I started in the US, now I'm in London. When I fire this thing up, I know that, the mom is over here, and I will self-configure and make that connection for you. So we've done a lot to kind of help that process through. Yeah, does that answer the question?
Yes, kind of. But you don't have like a lightweight client or agent that you can install on a laptop so that the mobile user can connect to the other endpoint, which is kind of static, where where the data resides while roaming and accessing it. Or if you still don't have it, do you plan to have it in the future?
Yes. Yeah. That's actually something that we do. We're Harry's goal in life was to make sure that we can put this technology on a phone, right? So, right, yeah. It is in the works. The plan is to, it's a VM, but we want to make it very, very lightweight. I want to make it an app. I want to make it something that, you can drop on without having to have a lot of infrastructure behind it. Because a VM, it could be a little heavy at times. So yeah, that is very, very something that we're interested in. Harry, you want to add something to that?
Yeah, Pedro. So remember that we'll work over any IP network. So I guess I would just tell you that for a government customer recently, you can imagine that they have things that are not stationary. And we were able to demonstrate actually both over satellite and over a 5G network that literally they put up at the last second, someone put a hotspot on land, and literally from on board this thing that moves, I won't say how, the people on land were able to actually see what it was capable of doing and vice versa. So that access was happening literally over both satellite and 5G. So it really depends on, is it small enough yet to fit on an iPhone? No. Am I driving my team crazy telling them that we'll know we got there when that happens? Absolutely. This clearly, we actually are working with a partner who's trying to implement a light VM on a laptop, but we got to even get smaller than that. So that's something we're working on very, very hard, as you can imagine, because clearly, as we're all little talking heads on screens today, everyone is going to be more mobile and in more different places than ever, and you have to have that capability.
Because you basically have to re-engineer the client part of the end-to-end connectivity so that it fits on mobile devices, right? This is the
correct. And how much of what functionality do we really need there to have a thin client?
Right. And remember, the guys, the idea is that, and ladies, thank you. The idea is that, think autonomous vehicles right now, right? The car pulls into the shop, and it's got tons and tons of data that it takes more than a day to move. Now, all of a sudden, you can instantly access that data over distance. But a better approach, and what we're leading towards is, hey, get into smart cities. If I can put these in the cameras and the 5G towers and these kinds of things, all of a sudden I can create an architecture where I can have a federated compute platform. Compute could be anything, but I don't have to have copies of data for it to work on. Right now, I can create this mesh of compute and have them instantly access a centralized component of information and do compute on it in real time. Right, and that's kind of what we're after. So it's a different approach. Okay.
This brings up another question. So how do you manage complex environments like the one you described, even if you are not there? But I think that government, and large enterprises have multiple locations. So
sure,
do you have a management tool that takes into account all of this? I mean, upgrades, status checks of all the devices and so on.
Yeah, that's a good question. So we actually do. We have a single pane of glass management tool that allows you to see the whole overall architecture, configure it, and dive in if there's issues. But personally, that's great. My approach is expose all the information so that if somebody does have a larger management suite, that we just plug into that and make sure that we provide all of the cues that allow them to not only see what's going on, but be able to make the changes. So it's kind of a combination of the two. Yeah.
So I noticed on the hardware acceleration that you were using FPGAs. Can your software leverage ROCE or iWarp functionality that's built into some NICs for some sort of a hybrid approach in between a VM state and the hardware accelerated state with FPGA?
Actually, so for Rocky, yes. We don't do anything with iWarp. That's just a business decision. But for Rocky, sure. In fact, we actually have kind of under the hood a virtual RDMA Rocky adapter driver kind of per se. So part of it is to say, okay, let's go into some of the virtual environments and say, here's because some people have RDMA drivers already, but I can give you a new RDMA driver that actually lets you use RDMA over distance, which is different, right? So yeah, that's actually in there, but not for iWarp.
I'm curious if Vcinity, I guess, I don't know what you call the components, but the part that sits on the server side, the file system side, if I'm on a client and I want to copy something from one file folder to another file folder, typically that's just a rewrite function, right? It's just rewriting pointers on the file system itself. It's not actually moving the bits and bytes from one section of the drive to another. Is it doing the same thing there, or does it act like it has to pull it to the client and then push it back and rewrite it?
No. So it's exactly what you said for the first time, right? The idea is to keep all the metadata in sync over distance. And the only time we're going to actually physically move that data is if you're pulling it, because it's more of a pull function than push, right? But you're going to pull it and then put it somewhere kind of outside of the Vcinity environment where it physically has to get there. But yeah, the idea is to actually just, if I have a petabyte of data and I need a file, I want to access the petabyte. I don't want to move the petabyte. Right. So, yeah, that's a good question. Yeah.
When you talk about latency on your devices and stuff like that, can you theoretically have over a great distance, a VM on both sides, or would you require hardware acceleration at one point?
Oh, no, you can just do VM to VM if you want. It's really a speeds and feeds. So conservatively we say, hey, anything up to about 2 gig of throughput, the VM can handle, right? If you want to have thousands of users on a 100 gig link and you want to actually move lots of data, the little VM's probably not going to work, right? So that's where we're going to throw some hardware at it. And just so you guys know, when we say throughput, our term of throughput is a little bit different, right? If you think about the way normally people would respond to throughput, it's, hey, I've moved this many bits, right? That's my throughput. The problem is traditionally, 50% of those bits are overhead bits to keep TCP and UDP kind of going, right? There's a lot of just overhead to make it go. We've changed that math. And the ratio for us is, it's really 5%, maybe 10% is kind of the housekeeping, the overhead bits. The rest of it is data. It's the good put. So even the term throughput for us is fundamentally changed, right? So I just want to make sure you guys understand that as well, because it is different. Yeah.
Question on the security side of things. So you had a lot of stuff where you're not moving the data, and I get it, you're kind of accessing it in chunks when it's necessary, but to do that, you have to provide access to it. So how does the security of the data work? It sounds like it's mostly just that you're not You're only providing access to certain chunks, and it should be ephemeral on the client end. So as long as the client isn't persisting any data as like local cache or anything like that, then the security of the main data repository remains more or less intact, other than the network being open to that endpoint.
Correct. So if you think about, for example, GDPR, right? We're not saying we're GDPR or anything. What we're saying is, if you have, we do a lot of media entertainment where I have $1 billion movie and I want to use cloud for rendering, but I'm not going to let my data go. Or, COVID research lab, I need compute, but I don't want to release my data. In that case, yeah, you're actually right. We're only moving the things of interest into memory. And unless the compute and the application actually creates a work product, a file save as something or other, then as soon as that app closes, there's no data that actually it resides. Does that help a little bit?
It does. I think the various lawyers are going to have to start wrestling with what does it actually mean if we have people who are not in the location but can totally access the data. Is the data actually there or not?
So it's an interesting comment, Justin, and I can tell you that we have a customer. It's a big post-production house, lots of special effects and those kinds of things. And we were on a call with them last Friday, and they actually shared with us, I don't think I can say the name of the studio, that one of the major studios whose name you would know and is associated with Magic has actually most recently included in their contract a whole new section that says, you guarantee that you will never, ever, 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 ever store data in the cloud, right? And so, and we've talked to everything from financial institutions to others. And, the issue on GDPR, there's a whole front end of it that's about consent, right? And then there's a whole bunch of it about when you can move it. And the whole point is, if you've never actually creating a copy outside, everyone we've talked to so far feels pretty comfortable that other than literally not moving it at all and moving compute to where the data is, there's no other way to get close to what we can do for them.
Yeah, but the lawyers have to get involved. I agree. We provide the mechanism, they provide the policy, right?
What happens if you have a massive update of the metadata in the file system? I mean, everything works if you move, a little bit of metadata and, large chunks of actual data. But what happens if it is the contrary?
Yeah. So, I mean, that is an issue. And we've actually created some technology that's just at a very high level, almost like walking a directory. We're going to go in there and we're going to do metadata checks. There's always the trigger mechanism. We know something has changed. We're going to make sure that we're coherent across. But if nothing has changed, we want to make sure that if you have 1 billion files and you do a directory walk, that you're not sitting around for an hour waiting for that to occur, right? So we have some things that are running on the back end, some daemons that kind of help through that process. That's actually a really good question, because we've had some customers that, I can get all my data great, but I have media entertainment, especially, tons and tons of these small files. And if I do anything, then, it's a problem that I don't want to have to wait for. So we try to help through that process. Yeah. That's interesting that you caught on that.
I feel your pain on that too, guys. I've been using GPFS since the 3.0 days, like back 15 years ago. And so I guess one of my questions too is from a deployment perspective. So you're using, Spectrum Scale on the back end. Do you typically, when you do a deployment, within an enterprise by like going in and doing kind of a professional services based on what they have existing in their environment to tie into that? Or is it primarily going in and kind of setting up a new kind of data repository for them in a lot of the situations where you go in to do that? Yeah, so it's actually a little bit of both. So we have some customers say, look, I have Isilon, I have Hitachi, I have Weka, whatever. We're just grabbing an NFS export, right? So that's the simple part. You put our VM in and you instantiate it, you grab the export out of the array, and off we go. And then we have some other customers that say, what, I want you to actually manage my tier 0 kind of storage per se, in which case Scale affords us the opportunity to have, petabytes of data under the hood. And then in that case, the NSDs that are part of Scale become a storage tier in that location. And we've done both. We don't really care. It's really what the customer wants and what they're really after at the end.